Okay, so graphing systems of equations. Systems of equations are just two or more equations solved together. That's an H, I promise. Okay, and their solution is where the lines touch or intersect. Whoop. Jesus. I have no idea. Okay, anyways, so knowing that, the first part says part 1, decide whether an ordered pair is a solution to the system. Okay, so to be a solution to the system, it has to satisfy or make a true statement when plugged into both equations. Okay, so if I plug this 12, 6, x, y into this equation and this equation, they should both be true if it's a solution. So I have 2 parentheses x is 12 minus 3 parentheses y is 6 equals 6. And then I'm going to type it in my calculator and I'm going to see if it's true. So I have 2 times 12 minus 3 times 6. Does it equal 6? Then it made a true statement. So this first, it is a solution to the first equation, but to be a solution to the system, it has to be a solution to both. So if I were to plug it in here, I have x is 12 equals 2 times what's y? Well, y'all, what's 2 times 6? So does 12 equal 12? So is it a solution to the system? Yes. Okay, so now look at number 2. I want y'all to start it while I take attendance super quick. So if I plug it into the first one, it should equal 3. And if I type in my calculator, -1 plus 2 times 2, it did equal 3. So it does satisfy the first equation. However, if I type it in the second one, x is -1 minus y is 2. Does -6 equal 6? No, so this does not. So therefore, this is not a solution to this system. Any questions of those? Pretty simple. Okay, so when it comes to part 2, it says kinds of systems. We call this KOS. It's just takes up less space. Okay. There's 3 kinds of systems, so that's why I have 3 graphs. So the first kind of system is what you see the most. And it's something that looks like this. Okay, so I want you to realize these 2 lines have different slopes. Y-intercepts don't matter. Okay, they have different slopes. And they touch how many times? Once. So what solution is that? Well, we can say that's like -2, 5. I'm just making up numbers. and I just made up lines. So this is negative 2 comma 5. That would be your solution. Don't tell me one solution. Yes, I know there's one solution, but your solution is the actual point where they touch. Okay? Now, when it comes to kind of system, KOS, this one is independent because they are two different lines, but they touch once. Okay? But they're consistent. So they're independent because their lines, their equations are totally different. Okay, but they're consistent because they have a solution, they have a spot on both lines where they are the same. Okay, now I know when you're working these out, it's a pain in the butt to write those two big old words, so you can just write I and C. Independent and consistent. So your next type of graph is something that looks like this. What do you notice? Yeah, they're the same line. So they have same slope and same y-intercept because they're the exact same line, right? So when this happens, your solution is anywhere they touch. And don't these touch everywhere? So we call this IMS. Does anybody remember what IMS stands for? Perfect. Infinitely many solutions. We like abbreviations in this unit. Okay, so my kind of system, well, this is dependent, and because the two lines are exactly the same, right? They're the same thing. So it's dependent, but it's still consistent because it still has a solution. It has a million infinitely many solutions, but it has solutions. So we can shorten this to D and C. And then our last type of solution is going to look something like this. What do you notice? They never touch because they are parallel. Parallel means they have same what? They have the same slope. However, they have different y-intercepts. Well, if my solution is where they touch, what's my answer here? No solution. So remember, that's your fancy symbol, but that just means no solution. So your kind of system here, because they never have a solution, is just inconsistent. Or I. Okay, any questions with that part? Okay, so if you start looking at the next one, it says find the number of solutions without graphing by only paying attention to slopes and intercepts. Well, we know if they have a different slope, because it says just find the number of solutions. So I want you to realize these are your options. You have one solution as an option. You have infinitely many solutions as an option, and you have no solution as an option. So those are your three options. Because it's not asking me to find the actual solution, it's just asking me how many. So those are my three options, yes? Because those are the three different types of solutions. So knowing that, I know when it's one solution, it's because they have different slopes. I know when it's IMS, it's because they have the same slope and same y-intercept. And I know it's no solution when they have same slope, different y-intercept. Yes? So on all of these, we need to find slope and y-intercept. Okay, so let's get started on the first one. Sorry, I have the yawns. Okay, now you'll see that this is in standard form. It is not proper standard form. Okay, but it's also not hard to solve for y. So you can solve for y, or you can put it, just do the improper standard form stuff. So I'm going to go ahead and solve for y. I think it's easier. So I'm going to bring this over here, and I have 1/2 x minus y equals 2. Now typically I would move my x, but then I'm stuck with a negative y. So I'm going to move my negative y. How do I move a negative y? Add y. So I'm going to put plus y, plus y. And I have 1/2 x equals 2 plus y. How do I get y by itself now? No. Minus 2, because I have that 2 and they're being added together. So minus 2, and now I have 1/2 x minus 2 equals y. So knowing that, what's my slope? Now that y is by itself, what's my slope? A half. So m equals 1/2. And what's my y-intercept? Negative 2. Okay, now for my other equation. Now this one, you can do it multiple ways. Y is not going to be as simple to get by itself. You can still do it that way if you'd like. So let's actually do it that way, and then I'll show you the other ways on the other ones. So here we have x equals 2y plus 5. So what am I going to do first to get y by itself? Y is positive, so I don't need to move y. So what do I have next to my y? The 5. How do I get rid of plus 5? So I have x minus 5 equals 2y. Now what's my last step? To get y by itself. Divide everything by 2. Divide, divide, divide. And now I have, I want you to realize that's a 1x, so 1/2 x minus 5 over 2 equals y. So what's my slope on this one? And what's my y-intercept? So what matches? My slopes match. Does anything else match? No, so which one said same slope, different y-intercept? What was my solution there? So this would be no solution. Because they have the same slope, but they have different y-intercepts. So if you were to graph this guy, it would look something like this. And they'd be parallel and they would never touch. Any questions with that? Okay, so let's look at example 2. So I'm not going to solve these for y because they are in proper standard form. And I know how to find my slope and my y-intercept from proper standard form. So slope is opposite of a over b. So what's the opposite of 3? Over exact b. And 2 negatives makes a. So this becomes positive 3 or positive 3 over 1. Either way. Okay, so knowing that, I need to find my y-intercept. Well, y-intercept, remember, is where x equals 0. So if I were to plug 3 times 0, well, what's 3 times 0? So wouldn't that just cancel this piece? Now how would I solve for y? Divide by negative 1, and what am I going to get? Negative 4. So I know my slope is 3 and my y-intercept is negative 4. Okay, so now let's find the equation of the other one. So, or not the equation, sorry, the slope and the y-intercept. So first off, I'm going to find the slope. So that's opposite of A over B. So what would that be? Well, before I even keep going, what do I notice? Well, look at the slopes. Are they the same at all? What's the only one that has different slopes? How many solutions did it have? 1. So how many solutions is this going to have? And it's because they have different slopes. So if I were to graph this one, it would look something like, and then this one has a negative 1/2. It's going to look something like that. So it only touched one time. Okay, so now looking at example 3. It says negative 2/3 x plus y equals 6. Well, if I wanted to solve for that one for y, would it be super quick? Don't I just have to move x? Y is already kind of by itself. There's no coefficient. So I can do add 2/3 x, add 2/3 x, and I get y equals 6 plus 2/3 x. Are we okay with that? So this is my slope, and this is my y-intercept. So now let's do the other one. So this one, now this one is not in standard form either. Is y also easy to get alone here? Couldn't I just divide all 3 terms by 3 and then y will be by itself? Yeah, so let's divide. And I get y equals 2/3 x plus, what's 18 divided by 3? 6. So I know my slope is m and my y-intercept is 6. Well, what do you notice? They both match. So what does that tell me about it? How many solutions am I going to have? IMS. So if I were to graph this one, it would look like this, and when I graph the other one, it would just be directly on top of it. Any questions with that? No? Yes? Okay, the rest of it, that was like the worst part, I think. The rest of it's pretty simple. Okay, so first off it says, just a reminder, well, we just kind of solved for x and y intercepts here, but as a reminder, how do I find x-intercepts? Do you hear it? Yeah, sorry. I wish. That's why I love the portable. Y'all, I'm so sad I don't have a portable anymore. Okay, anyways, let's finish, and then we'll go look out the window. Okay, okay. So to find your x-intercept, you plug y equals 0 in and solve. Plug in y equals 0 and solve. And then this y-intercept is the same thing. Plug in x equals 0 and solve. Okay, don't make me cry. What does HOI stand for? Horizontal. 0 slope. Not intercept. It's a y equals equation. So I'm going to write y equals a number. And remember, it has no x. Okay, what about VUX? Perfect. Vertical, undefined, x equals a number, and it has no y. When you're done writing that down, flip to the back so I know. You'll have some time next week, but there will be time today. So I'm actually going to only do number 1 and 2 fully, and then we're just going to talk about 3 and 4 because, honestly, y'all, in this unit, we're going to learn that there are 3 different ways to solve systems of equations. This is the first way, it's graphing. The other way is elimination, which I call big addition, and your last way is substitution. Okay, you have learned this in Algebra 1 and in Algebra 2. Okay, but, I mean, everybody needs a refresher. So, graphing, y'all, when's the best time to use graphing? When they're ready to graph, right? When they're y equals equations. When they look like this, you're probably not going to do graphing. You'll probably use one of the other methods because it's not set up for graphing. Does that make sense? So most of them on your practice look like this. And that's what I want to focus on. So knowing that, let's go ahead and graph. So first off, these are y equals equations. Can you use it in your calculator? Yes, so I'm going to do one in my calculator, and I'm going to do the other one by hand. So alpha y equals enter 2 over 3 x minus 1. So knowing that, I'm going to hit second graph because the table is what's going to help me. And you only want pretty points. So I always scroll up to about -9 or 10 because that's as far as I can go on my graph. So at -9, I'm going to put a point at -7. So -9, -7. And then I have a point, only pretty points, so -6, -5. -3, -3. Zero, -1. 3, 1. 6, 3. And I think that's about far enough. So you're going to draw your line. And there's my first line. Yes? Now I'm going to show you the second one by hand because that's how I prefer. I feel like it's faster if you know what you're doing. If you don't know what you're doing, use the calculator. Okay? So the second one, I know that since y equals, it gives me my y-intercept, which is my number by itself. So this is my y-intercept. So at +2 on the y-axis, I'm going to put a point at 2. And I know my slope is -1/3. So I'm going to go down because it's negative. And remember, your bottom number, always go right first. Okay, so I'm going to go down 1, right 3. Well, what did I find right away? Did I find where they touch? Yep. Okay, so on your second line, you don't really have to go all the way across. You just really need to find where they touch and draw your line. So when it asks for a solution, what is your solution here? Well, where do they touch? Yes, sorry, I was going to tell you all yes, but I was sneezing. Okay, in your kind of system, so remember we have independent and consistent, we have dependent and consistent, and we have inconsistent. Well, it has a solution. So I know it's either independent or dependent and consistent. And this is independent because the lines are different, but they have that consistent point. So this is independent and consistent. If there's one solution, it'll always be I and C, independent and consistent. So let's look at the next one. A lot of people struggle with graphing this. Do not let this throw you off. It's a linear parent function. Does it have 2 letters? So do not draw a horizontal or vertical line because horizontal and vertical lines are when you only have one letter, not the other, yes? So don't do that. I saw that a couple times, and I don't remember this class, but in one of my classes. Okay, so knowing that, I want you to realize this is the same thing as writing y equals 1x. And if I wanted to add something to it, what could I add to it? Well, what can I add to something that won't change anything? 0. Adding 1 will change it. Multiplying by 1, no. So it's just telling me that it goes to the origin when there's no plus or minus. And then my slope is 1 over 1, so I'm going to rise 1, run 1. And you'll notice all your points are like 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, because x equals y. They have to be the same number. Does that make sense? And then draw your line. You want to plot most of them on your first equation because you never know where that second equation is going to touch the first line. But on the second line, I'm really not worried about too many points. Like on this one, we only plotted 3 because we saw our solution right away. Does that make sense? Okay. If you only plot 2 and your solution's like way over here and your line's not 100% accurate, you might get the wrong answer just because you drew your line crooked. Does that make sense? That's why I always want the first line all the way across and then the second line until you get to your solution. Okay, so then this one tells me x equals -3. What kind of line is that going to be? Vertical. It's VUX. Vertical, undefined, x equals a number equation. What does x equal? -3. So I'm going to just draw a vertical line. And where do they touch? -3, -3. And my kind of system, because it only touched once, is independent and consistent. Any questions with that? Okay, like I said, the bottom 2 I'm just going to kind of sketch. You're not going to sketch on your practice though, but I want to give y'all more time for practice. So on the bottom 2, they're both in standard form. I'll put those back up in just a second. On the bottom 2, they're both in standard form, so you'd have to find your slope and your y-intercepts, right? So knowing that, if I were to find this one, I believe they both start to look like this. And they have the same slope and a different y-intercept. So will they ever touch? So when I say solution, what are you going to put? No solution, because they never touch. So our kind of system here is inconsistent because there's never a spot where they're the same. So it's inconsistent everywhere. I had sneezes. Okay, this next one, if you were to solve it, I knew it was coming. Okay, this next one, if you were to solve it, you're going to graph it and it would look something like this, which tells me what? Infinitely many solutions. MS, because they are the exact same thing. Okay, and my kind of system would be dependent and consistent. It still has solutions, but they're the exact same line. The equations, there's nothing different about them. Any questions with that? Okay, so I sketched these. Are you going to sketch on your practice? No. Okay, your practice is on the next page. Yes, it is a front and back, but the back is like 2 super short questions. And we're going to cross off one of the graphs. Okay, I numbered them terribly too. So you'll see 4, 5, 6, and then you have another 4, 5, 6. That's not my bad. I was copying and pasting because I was putting new graphs on here because the other ones were terrible. So that bottom left number 4, you can cross out. Okay, the rest of them I want you to do, but what do you notice about all the equations? Except for how many? One single one. Okay, so I was nice when I gave you all your equations, okay? So this is what you're working on. Ready, go.